Biomolecules are complex organic molecules which build up the living organism and form the basis of life. Biomolecules include carbohydrates, proteins, lipids, nucleic acid, etc. Carbohydrates are polyhydroxy aldehydes or ketones or compounds which can give them on hydrolysis. The examples are glucose, fructose, etc. In glucose, we can see that there are 5 OH groups. So it is a polyhydroxy compound. Along with that, the functional group in glucose is aldehyde. So glucose can be defined as a polyhydroxy aldehyde. So it comes under the category of carbohydrates. Carbohydrates are classified into sugars and non-sugars. Sugars are then divided into monosaccharides and oligosaccharides. Whereas non-sugars are classified into homopolysaccharides and heteropolysaccharides. Monosaccharides are then further divided into aldoses and ketoses, whereas oligosaccharides are classified into disaccharides, trisaccharides and tetrasaccharides. Monosaccharides consist of only a single polyhydroxy aldehyde or ketone. The main examples are glucose, fructose and galactose. They exist as single entities. They are not joined together. So they are called monosaccharides. Monosaccharides are classified into aldoses and ketoses. In aldoses, aldehyde is the functional group. Glucose is the main example of aldoses. Whereas in ketoses, ketone is the functional group. Fructose is the example of ketoses. Here we can see that glucose belongs to aldoses, whereas fructose belongs to ketoses. Oligosaccharides are molecules that consist of 2 to 10 monosaccharides joined together. If 2 monosaccharides are joined together, it's called a disaccharide. If 3 monosaccharides are joined together, it's called a trisaccharide. If 4 monosaccharides are joined together, it's called a tetrasaccharide, and so on. Sucrose is an example of disaccharide. It is formed by the combination of glucose and fructose. Lactose is another example. It is formed by the combination of glucose and galactose. Trisaccharides are formed by the combination of 3 monosaccharides. For example, raffinose is formed by the combination of galactose, glucose and fructose. Polysaccharides are formed by the combination of infinite number of monosaccharide units. An example of polysaccharide is starch. Now we will study glucose in detail. This is the open type structure of glucose. This structure was not able to explain many of the properties of glucose. So, a cyclic, closed, 6-membered structure was proposed, which are called pyranose structures. Now we will discuss the cyclisation of glucose. The OH group at carbon number 5 will change its position to carbon number 1. Whereas the oxygen at carbon number 1 will form a cyclic oxide linkage with carbon number 5. Resulting in this structure. Now we have to draw the cyclic 6-membered ring. We will start with oxygen. The oxygen is placed here. Next we have to number the carbon atoms. The carbon number 1 is placed here. Next, carbon number 2, carbon number 3, carbon number 4, carbon number 5. The carbon number 6, that is CH2OH, is placed above carbon number 5. Now we will be in a state of confusion where to place the substituent atoms or molecules on each carbon. As a general rule, all the atoms or molecules on the left side will be pointing up and the other atoms and molecules will be pointing down. For example, at carbon number 1, the substituents are H and OH. H is on the left side, So H will be pointing up and OH down. At carbon number 2, H will be pointing up and OH down. At carbon number 3, OH will be pointing up and H down. But in the case of carbon number 5, the substituents are H and CH2OH. Only in this case, CH2OH will be pointing up. Now we will study about anomers. Anomers are sugars that differ in the configuration at a single carbon atom, that is at carbon number 1. In the first structure we can see that the CH2OH and OH are oriented in the opposite direction. Such structures are called alpha structure. Here it is called alpha glucose. Whereas in the next structure, the CH2OH and OH are oriented in the same direction. Such structures are called beta structure. Here it is beta glucose. Now we will study about fructose. Fructose is a sugar found in fruits. This is the open type structure of fructose. We have to study the cyclic structure. The carbon atoms are numbered 1 to 6. The OH at carbon number 5 will change its position to carbon number 2, whereas the oxygen at carbon number 2 will form a cyclic oxide linkage with carbon number 5, resulting in this structure. Similar to the case of glucose, we have to transform this structure to a cyclic 5-membered ring called Furanose structures. The oxygen will be placed here. Next, the carbon number 1, that is CH2OH here. Next, carbon number 2, carbon number 3, carbon number 4, carbon number 5. The carbon number 6, that is CH2OH, will be placed above carbon number 5. All the atoms on the left will be pointing up and the others down, except in the case of CH2OH. These are the two anomeric forms of fructose. In the alpha D fructofuranose, the CH2OH and OH are pointing in the opposite direction, whereas in the beta D fructofuranose structure, the CH2OH and OH are oriented in the same direction.